In this video, I'm going to explain the rationale behind the Interpolation Accuracy lab assignment. So the purpose of this assignment is to assess the accuracy of the interpolated results using three different interpolation techniques: inverse distance weighted, natural neighbor, and spline, on three different grid cell resolutions at 0.25 meter resolution, 0.5 meter resolution, and 1 meter resolution. And from that data set, we're going to look and explore at the accuracy statistics that we use to quantify the quality of spatial data. So to that end, I'm going to go into our MXD and discuss the lab. So I have given you a set of points, and these points correspond to a digital surface model derived from a LiDAR acquisition for the white point area in Palos Verdes. So we have these points, and there's a lot of them. If I open the attribute table, there's almost 200,000, 195,000 points. So we're going to interpolate 9 surfaces from this set of points using IDW, spline, natural neighbor at 3 different grid cell resolutions. But before we do that interpolation, we're going to extract 10,000 points from this data set and save those as the validation data set, which we're going to use to validate or calculate our accuracy of our derived grids. So I'm going to open up the toolbox that I've provided for you in this lab. The first step is to take the DSM points, the points from the DSM, and we are going to use the Create Random Points tool. So what it's going to do is create a shapefile called random that's constrained to the DSM point. So it's going to randomly select, and I've put here 10,000. It's going to randomly select 10,000 points from this set of points and save those as a shapefile called random. It doesn't have any elevation associated with it. They're placeholders. So once we have that placeholder, we are then going to use select by location. And this time we get to use select by location are identical to. We're going to take those 10,000 random points and match them up with the DSM. And any place they're identical to, we are going to essentially select 10,000 points from that random shapefile in the original DSM layer. We're going to save those 10,000 points as a file called validation. So we're going to select those identical to, and we're going to identical to the selected random points and save that as our validation point file. And then we're going to switch the selection using the table switch selection tool. So we're going to switch the selection, and that leaves everything else but those 10,000 points. So everything else but those 10,000 points are going to be used as the basis for our interpolation. So we've stripped out 10,000 random points, set them aside, and if we go over here, you'll see that I've actually made a copy of that validation shapefile that we're going to use later. So hold on to your hats. Now we're going to get into the interpolation part of the model. So we have a set of points that we're going to use for the interpolation. It's those 195,000 points minus the 10,000 points. So it's about 185,000 points. So we're going to use this interpolation data set, and here we interpolate our 9 grids. We use natural neighbor at 0.25 meter resolution based on the Z value of elevation, and I'm forcing the 0.25, I'm forcing the grid cell resolution here. We have IDW and spline, natural neighbor at 0.5 meter resolution, IDW at 0.5, spline at 0.5, natural neighbor at 1 meter resolution, IDW at 1 meter resolution, and spline at 1 meter resolution. So we're going to run the interpolation and end up with 9 interpolated grids. And then we're going to use this cool tool called Extract Multi-Values to Points. What the Extract Multi-Values to Points tool does is it takes the validation for extract, this copy of the validation shapefile that we've copied, and uses that as a point locator and appends to its attribute table the co-located values in each of the input grids. So we have our 9 input grids, and we're going to take that point file, and for each elevation that was in the validation shapefile, pull out to its attribute table the co-located values in each interpolated grid. And then we can use the DBF for that shapefile as an export to bring in to Excel for calculation of our accuracy statistics. So without further ado, I am going to validate and run the model. And when you run the model, make sure that you do not have this box close. Don't close the dialog box, because at the end, what I'd like you to do is copy all of this text information so that you can also record how long it takes to run each interpolation. Just so that you can say, okay, well, maybe one interpolated grid is more accurate, but did it take a significant amount of time longer to produce? So I will pause the recording and come back when this model has run. Okay, so the model has successfully run, and it took about 10 minutes. I have the end time at about 6:30 and the start time somewhere here at about 6:15, so it took about 15 minutes to run. So this is the information that you will then cut and paste before you close out the model dialog box. You just control copy it and paste it into a Word document so you have that for future reference, so that you can record the time it took to interpolate each step, so that you can record that later. So for example, here's natural neighbor. At 1 meter resolution, it took 19.99 seconds versus natural neighbor at 0.5 meter resolution. That took 42 seconds, and natural neighbor at 0.25 meter resolution took 1 minute and 42 seconds. So the higher the resolution, the longer the time it takes to interpolate the surface. So it'll be interesting to have that in a table alongside your accuracy statistics as well. So if you close this box, you lose that. So copy and paste it, and then you can close the box. Before I exit the model, I would like to review the model properties with you. So what I want to point out is that I did not set raster analysis settings. I set the workspace to be the lab workspace, but the processing extent was set to the DSM. And that way, the output data sets are created with an extent that matches the DSM points. And we don't need raster analysis settings because each interpolation has its own grid cell resolution that needs to be specified. So you don't want that to be, you don't want to override that in the overall model properties. Okay, so those are the details on the model. And then now that we're done, I can add this to the display, and we can take a quick look at the validation. So if I open the attribute table, once it eventually draws, we have the elevation that are in those 10,000, almost 10,000. There are a few at the end that weren't included. Almost 10,000 elevation validation points, and then the co-located values in each of the grids. So for example, for this point, the value that was in the file says that the elevation was 35.182 meters. And in IDW, it predicted it to be 35.21 at 1 meter resolution, 35.20 at 0.5 meter resolution, and 35.26 at 0.25 meter resolution, and so on. So it was pretty close. For each of these points, it shows what the predicted value was given the interpolation, and this is what we're going to evaluate using our accuracy statistics. Okay, so these are our DSM points in yellow, and the validation points are in red. So you can see that the validation points are not located where the DSM points are. And maybe on your machine it'll draw a little bit more quickly. It may be because I have this background image in there. But these validation points are the points that were removed from the interpolation. So at this particular point, if I wanted to use the identity tool, for example, we could explore what that elevation is supposed to be at that location. It's supposed to be, if it had been included in the interpolation, 25.336. And then these are the numbers that it was interpolated for that location in these different grids. Okay, so we are going to take the DBF from this validation file, validation for extract for export, and bring that into Excel. Before we do that, we can go back into our model. And if we select model, delete intermediate data, and And then on our output refresh, it will remove all of the other intermediate data. It does keep the random file and the validation, which is what we want. So I will see you in the next part of this video where we are going to take the data in this attribute table and bring it into Excel.